Hello and welcome to Hadoop Exam Learning Resources. In this session, we are going to cover various kind of NoSQL databases, and then later on we will see the NoSQL implementation with their example. So let's start with the various categories of the NoSQL database. So there are generally four categories of NoSQL database of NoSQL database. First one is key value database. Under this, the mostly counts as the Redis, React, MemCached-DB. The next comes is MongoDB and CouchDB. Sorry, this is the type of the database, but the category is called document oriented database. Document oriented database. And third one is, I would say, column family database. This is very popular database. And among this, the most popular is Cassandra, and second one is HBase database, and from Google side is called Bigtable, and the fourth one is Graph database. So these are the databases which comes in the NoSQL database, and Graph database is example for this is Neo4j. It's a database which is NoSQL database. So now all these three database above is based on the aggregate orientations. All the data which is fetched together needs to be placed in the under one key and value. So that is based on aggregate orientation. So let's see each and every database in little depth, what exactly is their implementation and how they look. So let's first start with the key value database. Key value database has like the structure here. If I would draw it, so it's like hash table, and the Java is equal to hash table. So this is your key part and this is your value part. So this is as an hash table in the Java you would have. So this is like in Oracle RDBMS. If I would compare it, so this is equal to the row ID, and this is the value. This is the blob object. So binary large object. So any data associated with one key would be stored under one value, as in value, and one block. So whole data related to this key would be stored as a block inside this. So it doesn't care what exactly inside the blob exactly. So this could be user profile. So if you have user information and this is user ID, let's assume it. So and it's profile information inside this, and if this is the customer, then this is his order information in this blob object, and any other information like address or something could be stored in this value object, and this whole blob is stored into the value part of this object. So this is key value storage. Since key value storage always use this as a key, as a primary key access, so they have a great performance, okay, and can easily be accessed. So your whole data is stored as a key value, and key value, which is, so every record which is like key and value based tool, this can easily be scaled and easily be accessed, and they are in the better performance. So how exactly their structure is look like? So if I would say in the I as an analogy, this is table equal to bucket in case of key value database. So how exactly it looks like? So now I have user data information. Okay, so this is the Okay, so this is the bucket for the equal to user data. So name of the bucket or name of the table is user data, and the data stored in like one row is equal to that is that, so key would be session id for one row. So each session id which associated with the timestamp or some identifier is given to it, and the value object, okay, value object is stored inside this. So this bucket has, this is the one session id, then another session id information, okay, and value associated this with this another session id, and this is the value. So is stored, and then I would say this is the user profile information, and then after that this is some session data related to session for this user, and some shopping if he has done, then cart item information, this is another cart item information. So this way you can store this. So this is single key single object value with this tool. So now this is key value store, where we should use it and where we should not use it. So suitable use cases for like storing the session information, as we have already seen, it's good. Now next is user profile and preferences, as we have already seen. Profile and preferences, if you want to store, then you should consider it. And third is where you have shopping cart related information. So this example we have seen it. Now where we should not use it, this database should not use this database. Use this database. You should not use this database when there is a relationship among data you need it. So like foreign key relationship we have in normalized database, this kind of information you need, then you should avoid this database because it doesn't perform very well in case of relational database when relation is required in the data value. If you need relation keys or values, avoid using key values as we have discussed. And when multi-key transactions, so like whenever you want to do update, insert, delete, and wanted to maintain a transaction among the rows, various rows, like you wanted to perform update operation on all these three rows in a transaction, then you should not use this database because most of the database doesn't support transaction and ACID properties. Next is operation by sets. Operation by sets, I mean it's like the most of the queries you do is based on one key only, based on the individual key. So if you wanted to fetch all the record together or some kind of operation you want to do it, then avoid using key value database. And such kind of requirement is there, then it's application responsibility who is accessing this database should access this key one by one and aggregate their data. And fourth case where you should not use this database is when your query is based on value, like give me all the database price order is greater than $100, greater than or equal to $100, give me all of it. So this kind of data query, rather than on key value, it would be done on this value part, and it has to be iterated over it and to fetch it. So this is not good performance on this, but so you try to avoid this database, a key value database. Now let's move to the document database. This is also same database, same structures, not exactly same, but look wise, like this is key and value, but here key is like again some identifier, but value differs. So what exactly here is their value is a document. So your whole data stored in the document, and one document stores your data. So this document could be XML document, JSON document, or your own defined document, BSON document, custom document structure. So any document structure you can store it. So these documents are self-describing hierarchical tree data structures which can consist of maps, or this is different tags or collections or scalar values. You can store it in this kind of structure. So the best example of this type of database is the MongoDB, and in this series the key part is called underscore id, and the value is obviously we can see that is document. Okay, and then let me give you one example how data is stored and how it looks like in the document format in case of document structured database. So let's see, this is the document, JSON document. You would have first name, some syntax little different but somewhat similar, and first name John. Okay, now next is his likes, whatever his likes are, like you can say it's scalar arrays, like this is information stored in array. Okay, biking, photography, cycling or swimming, his likes. Okay, then his last visited city, it's Mumbai, or city where he stays as New Delhi. Okay, so this kind of JSON structure is stored into the value part, so you can easily query this data once you fetch this key based document based on the key, and then you can query the individual values in that document. So various document as shown different schema for all rows, so you could have different schemas. So like one row could have this kind of document, another document have another attributes, like you can say zip code. This has one row would have this attribute, but another row would not have zip code associated with this. So this way could vary. All documents could have different attributes, and city addresses or something inside they have maps, lists, any kind of collection supported. No need to explicitly store null values or something, you just skip or exclude that value, so you don't have to store that values over here. So now let's move to the where it's perfectly fit this kind of database and where we should consider using it. So let's the best example where we should consider using this is a event log. So there are applications where based on every event you want to log some information, that places you can store this information, like in the stock market price change, okay, or some other thing happens, user logged in your website. Okay, once user logged in your website, you want to get all the information from where location where it has logged in, what is the IP address of his machine, where it has been logged in, which browser he has used to log in, what keyword he has used to search and reach this website, and from which website backlink has been provided to reach this one. So this kind of real-time analytics, if you need it, then you can use this kind of database to store the value. The next is a good use case is content management, CMS database, correct? Where if you want to store your blogging websites, various websites, Twitter, or not Twitter exactly, it's perfect for LinkedIn profile. So this kind of databases will be used for your information to be stored. And now next, where we should not consider using this database. So that it's where you need complex transactions, like again same thing, because NoSQL database doesn't support ACID property. So if you need transaction, then avoid using this document oriented database. Second is queries against like your data changes, against your data variations. If your data keep varying and like schema changes, it's okay. But if your query also keep changing, like previously you are querying the 2 columns, now suddenly you are asked changing the query to fetch next 10 columns or something, some another rows or kind of, just keep changing query and variations. Like previously you are accessing this document which has all information, now another information second document, and you want to information from both the document in using one queries, single queries to fetch document 1 and document 2 from both the document. Then it's, you should not use this document oriented database. Now let's move to the another database, that is column family database. So column family database. So column family database is the a very popular database among this is the Cassandra and HBase. These are the two popular database of column family database. So it exactly allows you to store data with the keys. Again same thing, and mapped values to it, but these values are stored in the column family. So what exactly is column family? So let me define the terminology in column family database. So like this is the key space is equal to, in your Oracle database, is equal to the database. Okay, so schema, or you will generally say one user is one key space, and in database you would have various tables, correct? Various tables, table 1, table 2. So like profile information in one table, then another table is order information or something kind of. So similarly in key space you would have column family 1 for profile, column family 2 for order. So this is the column family, and third level is inside this is the, this column family has storage. This is key and value associated with this, key and value associated with this, key and value. Similarly in RDBMS, in Oracle Sense, you would have row ID and then whole row. This has similar structure, 8 columns in each row, so every row would have 8 columns. Okay, so and row ID is assigned to this. But in case of column oriented database, this row would have 6 columns, this row would have only 3 columns, this row would have millions of columns attached to it. So this kind of variations is there in the column family database. The important things here is every row is assigned one key, unique key. Okay, unique key for whole key space, but this is also in the ordered format. Okay, and similarly all the columns which has identifier. So this column name is actually, or if you not provide column name, so this is also but in ordered way. So this is also is ordered. So whatever column you would make it, store it inside this, it is always ordered before making the final persistence. Okay, so these are in order, so fetching and every time data would be faster. Now last unit on this is like after row level is a column unit. Okay, that's one column is the lowest level of this is column. So in RDBMS sense you would have column key and value. So column name would become your column key and value. So similarly here in column family you would also have 3 attributes rather than 2 attributes. One is column name, second is column value, and third one is integer assigned to this column, and that is time clock, that is called timestamp. So this is time clock. However, you should not use in your application this value, you should use only key and value in your application, because this timestamp is used by the database itself to persist the data around the cluster. Okay, so to make everything in the bring in the consistent state. So this way this data is stored in the column family database. So let me give you the example. If I would want to store the data for the customer, okay, and I have 2 things to be stored. One is profile of the customer and another is order information of this customer. However, most of the time for my analytics purpose, I will exhibit order information. I will fetch it frequently, and profile information for another purpose. I will to show the relevant order to that profile. I will use another's too. Uh, what I will, while designing my database, I will put profile information in column family 1 and in order information in column family 2. So because the information which you need regularly in one shot, you would put in one column family. The reason being, the information which you would store in the one column family at persistent level, or what I would say disk level, will be stored together only. So if you have two column family and this is your disk, okay, where you store the data, so this whole column family data is stored into one file, physical file, into the hard drive, and similarly order information would be in another physical file. It's sort of different. So whenever some data has to be fetched from that file, only one file would be accessed, because this is frequently used data, and this is all the information is in ordered format, so it would be easily accessed and would be used by the application. So this way we will store the data in the column family database. So this the popular databases among this way I've already told you is the Cassandra. So Cassandra doesn't have master node concept, so everything is in a ring architecture most of the case. So all the nodes are, so whenever client queries the data, whichever node is nearer to it will return the data, because it has replicated copy. If not, then it will ask nearer node to give the copy, and then the data would be returned by this. And in case of HBase, there is a master node concept. So if master node goes down, then whole cluster would be down. So now let's move to the point where we will discuss suitable use cases for column family databases. Suitable use case for column family database. So this is the most important, is again event logging. So real-time analytics can be run on this. We already discussed this. The next is content management system. Okay, we have already discussed this again, so you can use it. And third one is very important, is expiring uses. Okay, expiring uses means what exactly is here. If in Cassandra database, each column can have some time information where it will say after 6,000 or 60,000 seconds this column should be deleted. So if you would have user information in this column, and this user, okay, this is some user ID is assigned, you don't want it to be logged in after 60 days, so you will give him the access for some particular content for 60 days or something. So you can just give timestamp to this particular column, and after 60 days by Cassandra itself this column will be deleted, so he will no more be able to access this kind of whatever access he is not allowed to do after 60 days. So maybe at this place, or similarly expiring uses is helpful when you have advertisement information. After 60 days this advertisement automatically expire. Some job posting or something, after 60 days this job posting should automatically expire. This kind of requirement if you have, then you can consider using the column family database. And again, where you should not use this column family database, then again the same thing is, if you need ACID properties like transactional information, then you should not use this database. Aggregate functions like sum or average kind of thing, if you need it, then avoid using this database, because you have to fetch each an individual value and you have to aggregate it at the client side, because database directly doesn't support it. Or if it supports it, like in HBase, it has to run the map reduce algorithm, and it will take time to get the actual output or something. However, it's some databases are good on this or some are not. And the next, if your schema keep changing, then it's fine, then it is good to use NoSQL database. But your query keep changing, like as we have already discussed, like if you are start joining the data from various column family, then you should avoid using the column family data. So these are the three database we have considered over here. So now let's move one more important concept, that is called polyglot persistence. Okay, what exactly is polyglot persistence means? Okay, so before moving to this picture, like polyglot persistence means, that is very important concept nowadays. Like whenever you have requirement to like store some information in key value database, some information in RDBMS, there is a requirement while designing the use application. There's a different use cases for each kind of database. So sometimes you need document database, or so final solutions comes like mixing of all the database to bring out your more performant and better solution for your while architecting your application. So and this terminal and this concept is called polyglot persistence. So let me give you one example for polyglot persistence, that is this one. This is one e-commerce platform where I'm designing some e-commerce applications or something like Amazon e-platform. So if you want to store all the shopping cart or session data information, then you should consider using key value store to store the shopping cart and date session data information. If you want to store all the completed orders, so you just which is not regularly accessed, and if still you want it, then you can use the document store to store this database. Then later on, inventory and item price information you want to store it, and user should can change this value, some discount can be added. So RDBMS is a good fit for this kind of data persistence. Now at last, if you need relationship among all the customers, or you want to make relationship among the items, or then if you want to make some graph or something to make the relationship, you should consider using the graph database. So that is all combination of 4 different database in one platform, that is called polyglot persistence. So whenever you need this architecting new applications, then keep in mind like which one fit, because one solution is never perfect fit for all the requirement. So thanks for listening. So now let me give you a little update on the hadoopexam.com. We have recently updated developer simulator, which 45 questions with explanation has been added, which will help you to clear the Hadoop certification. And I will guarantee you, if you will finish all 240 questions, then you will definitely clear the exam, that is for sure, if you seriously read about it. Now next, in the simulator perspective, we have recently launched another simulator, that is HBase simulator, which has 225 questions in this. So if you are going for HBase certification, then I strongly suggest you go through this simulator. This has very well explained and 225 questions which are almost realistic to the exam. Okay, so it would definitely help you and you will clear the exam in one shot. Now next is the third solutions, like in Hadoop training, professional training. Now recently we have added multi-node cluster, so 3 node cluster solution end-to-end, and running the example and job tracker UI and name node UI, and everything has been shown clearly. Like it's very rarely you find this kind of step-by-step process. With the one PDF will also come with attached with this training, so you can set up your own multi-node cluster, and within just 45 minutes you can finish it out the multi-node cluster by running an example. That would help you to understand a lot in the big data, how to work on Hadoop. So keep visiting hadoopexam.com. I'm sure you will like it. It's like we will always try to keep the training quality maintained. So if you have any feedback on this our training, so just send us on admin@hadoopexam.com, so and we will improve it on each product, and we will create okay, if you find any problem with the training modules, then we will re-record this training module. Just let us know. Okay, and our training cost is just $60. Compared to any other vendor, nobody can give you this quality training on this price, I'm sure. And we have recently reached to the 2000 and 26 plus subscriber to our Hadoop session. So please keep visiting us and believe in us. We always try to keep you give you the best quality in Hadoop training. So these are our logo for hadoopexam.com. So thanks for listening. Hope you enjoyed this lesson. Thank you.